Hello everyone. Today I discussed a topic in statistics, that is correlation. What is meant by correlation? Correlation. Correlation. That means relation between two. If x and y are two variables. X and y are two variables. If there is any relation between two variables, how to check whether these two variables are related or not? We check by using the coefficient of correlation. Before going to coefficient of correlation, first we discuss the correlation. What is meant by correlation? Correlation is a statistical technique which is used to measure the closeness of the relationship between the two variables. Correlation means it is a statistical technique and it is used to measure the closeness of the relationship between the two variables. Okay. Correlations are of three types. Correlations are of three types. First one is positive correlation and second one is negative correlation and the third one is zero correlation. There are three types of correlations: positive correlation, negative correlation, zero correlation. First of all, what is positive correlation? Positive correlation means if we take the two variables x and y, if x increases, then y also increases. If x decreases, then y also decreases. If x increases, then y also increases, or if x decreases, then y also decreases. That means both the variables x and y moving in the same direction. If one variable increases, then the other variable also increases. If one variable decreases, then the other variable is also decreases. So this type of correlation is known as positive correlation. That means the two variables are in direct proportion. If one variable increases, then the other is also increases. If one variable decreases, then the other variable also decreases. Then we say that the two variables are in direct proportion. So this positive correlation is also known as direct correlation. Next, second one is negative correlation. What is a negative correlation? Negative correlation means reverse. If x increases, then y decreases. If x decreases, then y increases. If x is increases, then y decreases, or if x decreases, then y increases. That means the two variables are in opposite direction. That means the two variables are in inversely proportional. So then we say that the two variables are related in negative correlation. There is a negative correlation between the two variables. If one variable increases, then the other variable decreases. If one variable decreases, then the other variable increases. So this type of correlation is called negative correlation. Next, third one is zero correlation. Zero means there is no relation. If there is no relationship between the two variables, then that correlation is called zero correlation. These three are the types of correlation. Okay, positive correlation is also known as direct correlation. Negative correlation is also known as inverse correlation. Since here the variables are in inversely proportional. Here the two variables are in inversely proportional. So then we say that this type of correlation is called inverse correlation or negative correlation. Next, zero correlation means there is no relationship between the two variables. These three are the types of correlations. Next, how to measure the closeness of the relationship between the two variables x and y. It is calculated by using Karl Pearson's coefficient of correlation. Karl Pearson's coefficient of correlation. Karl Pearson's coefficient of correlation. Here Karl Pearson is a statistician name. He developed the concept coefficient of correlation. So with his name, this coefficient of correlation is known as Karl Pearson's coefficient of correlation. It measures the closeness of the relationship between the two variables. Here the Karl Pearson's coefficient of correlation is denoted by small r, and it is defined as r is equal to summation of xi minus x bar into yi minus y bar by square root of summation of xi minus x bar whole square into summation of yi minus y bar whole square. It can also be written as numerator is same, summation of xi minus x bar into yi minus y bar by n into sigma x into sigma y. These two are the formulas for coefficient of correlation. This is most probably we use this formula. If standard deviations of x and y are given, then we use this formula. Here sigma x, sigma y are the standard deviations of x and y, and here n is the number of terms given. So here what is xi and what is y, and what is x bar and what is y bar. Here x bar, y bar, xi, y. Here two variables are given, x, y. We take the sum of the values. If suppose x values 1, 2, 3, 4, 5. Next. And next the second one is 2, 4, 5, 8, 6. Okay. These are the x values and y values. X values 1, 2, 3, 4, 5. The corresponding y values are 2, 4, 5, 8, 6. Here the values of x are, these are denoted with xi's. This is x1, x2, x3, x4, x5. And the values of yi are denoted with ya. That means this is y1, y2, y3, y4, y5. There are 5 values. Okay, xi values and yi values are given. Based on the xi and yi values, first we find the x bar and y bar. The x bar and y bar are the mean values of x and y. How to get the mean values of x and y? Mean value means that is a average value. How to get the average value? Sum of the values by number of values. Here x bar, mean of x values, that is given by summation of xi by number of values. Next y bar. Y bar is the mean value of y, that is summation of yi by number of values. Here x bar and y bar are the mean values of x and y, which are given by this formula, summation of xi by number of values. That summation of xi means here there are 5 values for x, add all these 5 values divided by number of values are 5. Here y bar is summation of yi by n. Here summation of yi means add all the y values, 2 plus 4 plus 5 plus 8 plus 6 divided by n. Here x bar and y bar values are calculated by using these two formulas. We get x bar and y bar. Okay, xi, yi values are given. We find x bar and y bar. For getting the coefficient of correlation small r, okay, now what we have to find the values xi minus x bar, yi minus y bar, xi minus x bar whole square, yi minus y bar whole square. Okay, for this we form a table. Based on these calculations, we form a table for this. Xi values, xi minus x bar. Next square of these values, xi minus x bar whole square. Next yi minus y bar, yi minus y bar whole square. Next xi minus x bar into yi minus y bar. Xi minus x bar into yi minus y bar. For calculating these values, first we have to find the x bar and y bar values. What is x bar? X bar, summation of xi by n. 1 plus 2 plus 3 plus 1 plus 2 plus 3 plus 4 plus 5 divided by 5. The value is 3. Next y bar, summation of yi by n. Add all these values, 2 plus 4 plus 5 plus 8 plus 6 by 5. 6 plus 5 11, 11 plus 8 19, 19 plus 6 25. 25 by 5 is 5. X bar is 3 and y bar is 5. Okay, x bar, y bar we calculated. Based on these x bar and y bar, we calculate xi minus x bar whole square values, yi minus y bar y whole square values. Next product. First node on the xi values. For calculating the coefficient of correlation, we have to find summation of xi minus x bar whole square, summation of ya minus y bar whole square, and summation of xi minus x bar into ya minus y bar. First node on the xi values. Xi values are 1, 2, 3, 4, 5. Next, xi minus x bar. That means we subtract x bar value from each x value. Here x bar value is 3. Now we subtract 3 from each of these 3 values. 1 minus 3, that is minus 2. 2 minus 3, that is minus 1. 3 minus 3, we get 0. 4 minus 3, 1. 5 minus 3, 2. Next, square of these values. Minus 2 whole square, 4. Minus 1 whole square, 1. 0 square is 0. 1 square is 1. 2 square is 4. Add all these values, 10. 4 plus 1, 5. 5 plus 1, 6. 6 plus 4, 10. Okay. Here, this is the 10 is the summation of xi minus x bar whole square value. Add all these values, we get the summation value. Okay. Next, add on the ya values. Here, ya values are given as 2, 4, 5, 8, 6. Ya minus y bar. We subtract y bar from each of these y values. Here, what is y bar? Y bar is 5. So, we subtract 5 from each of these values. 2 minus 5, that is minus 3. 4 minus 5, that is minus 1. 5 minus 5, we get 0. 8 minus 5, we get 3. 6 minus 5, we get 1. Okay. Next, square of these values. Minus 3 whole square, 9. Minus 1 whole square, 1. 0 square is 0. 3 square is 9. 1 square is 1. Add all these values, we get 9 plus 1, 10. 9 plus 1, 10. 10 plus 10, 20. So, summation of ya minus y bar whole square value is 20. Next, xi minus x bar into ya minus y bar. Okay, that means we product of xi minus x bar and ya minus y bar, corresponding ya minus y bar. We multiply these two columns, corresponding values of these two columns. Minus 2 into minus 3. We get minus 2 into minus 3 plus 6. Next, minus 1 into minus 1 plus 1. Next, 0 into 0, 0. 1 into 3, 3. 2 into 1. Okay, 2 into 1, 2. Now, add all these values. 6 plus 6, 12. 7 plus 3, 10. 10 plus 2, 12. Okay. This is summation of xi minus x bar into ya minus y bar. Summation value is 12. Okay. So, for finding the coefficient of correlation, we find these summation values. Now, we substitute these values in the coefficient of correlation formula. What is the formula for small r? The coefficient of correlation small r is equal to summation of xi minus x bar into ya minus y bar by square root of summation of xi minus x bar whole square into summation of ya minus y bar whole square. Now substitute all these values here. Here, summation of xi minus x bar into ya minus y bar, that is 12. 12 by square root of summation of xi minus x bar whole square. Xi minus x bar whole square summation value is 10 into summation of ya minus y bar whole square. Here ya minus y bar whole square values, we add all these values, we get 20. This is the summation value into 20. So 12 by root of 10 into 20. That is 12 by root of 200. What value you get? By using calculator, we find all these calculations. 12 divided by square root of 200. So we get 0.8485. 0.8485. By using calculator, we done these calculations. Okay. This is small r value. This small r is the coefficient of correlation. This value is equal to 0.8485. What you have observed here, the R value is 0.8485, that is less than 1. Here the limitations for small r, the coefficient of correlation small r has the limitations. What are those limitations? This small r value is always lies in between -1 and +1. This r value, coefficient of correlation, is always lies in between -1 and +1. Okay. Here r value equal to 1. What we say? If r is equal to 1, that means there is a perfect positive correlation. That means x and y are in perfect correlation. That is a positive value. So there is a perfect positive correlation between the two variables. If r is equal to -1, then we say that there is a perfect negative correlation between the variables. If r is equal to +1, then there is a perfect positive correlation. If r is equal to -1, there is a perfect negative correlation between the variables. If suppose r is equal to 0, if r is equal to 0, then we say that there is no correlation between the variables. Either 0 or approximately equal to 0, then we say that there is no relationship between the variables. If suppose r is lies in between 0 and 1, if 0 less than or less than 1, then we say that there is a partial positive correlation. Partial positive correlation. If r value lies in between -1 and 0, then there is a partial negative correlation between the variables. Partial relationship only. If it is positive, partial positive. If it is negative, this is partial negative correlation. Okay. These are the properties of coefficient of correlation. R always lies in between -1 and +1. If r is equal to 1, then we say that there is a perfect positive correlation between the variables. If r is equal to -1, then we say that there is a perfect negative correlation between the variables. If r is equal to 0, then there is no relationship between the variables. If r lies in between 0 and 1, then there is a partial positive correlation between the variables. If r lies in between -1 and 0, then there is a partial negative correlation between the variables. This is about coefficient of correlation. Okay. Here, once again I repeat all these terms. First, correlation. Correlation means relation between the two or more variables. Okay. Here we are taking only the relation between the two variables x and y. Okay. Coefficient of correlation. It is a statistical measure which is used to find the closeness of the relationship between the two variables x and y. It is given by the coefficient of correlation small r, and it is given by the formula summation of xi minus x bar into ya minus y bar by summation square root divided by square root of summation of xi minus x bar whole square into summation of ya minus y bar whole square. Okay, for finding these values, we find first of all x bar and y bar values. Okay, x bar and y bar are the mean values of x and y, which are given by x bar equal to summation of x bar is equal to summation of xi by number of values, and y bar is equal to summation of ya by number of values. Okay, after calculating x bar and y bar, we form a table. xi minus x bar, xi minus x bar whole square, ya minus y bar, ya minus y bar whole square. Next, xi minus x bar into ya minus y bar. Okay, note the xi values, xi minus x bar values, xi minus x bar whole square values. Only add these values. There is not necessary for finding xi minus x bar summation, ya minus y bar summation. No need of this. Only what we want the summation values here. Summation of xi minus x bar whole square, summation of ya minus y bar whole square, and summation of xi minus x bar into ya minus y bar. We have to find only these three column summations. Okay, we substitute all these values in the coefficient of correlation formula. We get the value of r. This r value is always lies in between -1 and +1. If r is equal to 0, then there is no relation between the variables. Okay, this is about coefficient of correlation. In the next class, we discuss about the rank correlation. Okay, thank you.